Two of the following videos are true, while the other one is trash. Can you spot the fake? Season 4, Episode 8. Round 1, let's begin. This is a bottle of black printer toner. If I pour some of this powder into a beaker and mix in some vegetable oil, I've successfully made ferrofluid, which means I can take some strong magnets and bring them near the surface of the liquid, and the liquid gets pulled up towards the magnet, as you can see here. Inside this tube is a metal called gallium. I'm going to place this tube in some hot water for several minutes to melt the gallium, since gallium's melting point is just above room temperature. While it melts, I'm going to take an aluminum can and scratch the surface up quite a bit with a knife, like you can see here. This exposes the aluminum metal in the can. Now that the gallium is a liquid, add some to the aluminum can, spreading it out along those exposed scratches. After waiting a while, you see that the gallium weakened the aluminum can, and I was able to break the can open really easily with just my hands. If you take a Sharpie and accidentally put some on a whiteboard, you can use the fact that Sharpie is extremely volatile to your advantage. Take a heat gun and carefully heat the ink of the Sharpie without causing the plastic to warp. Now you can see that the Sharpie was removed where it got hot enough without damaging the board. You've now seen all three videos, and it's time to pause to vote in the comments for which one you thought was fake. Mixing black toner and vegetable oil does allow you to make DIY ferrofluid. Gallium also does destroy the structural integrity of aluminum, making it weak enough to pull apart easily with my hands. Even the exposed aluminum on the can needs to be scratched for this to work, because you need to remove an invisible layer of aluminum oxide that would normally protect the can from the gallium. Using a heat gun on a whiteboard with Sharpie does not cause the Sharpie to be removed. I simply faded in a circular masking of the blank whiteboard and added some feathering. Before we move on, I'm excited to announce that today I released Stick Scholars on Steam. Stick Scholars is an online social deduction party game you play with friends where players parkour to school, answer trivia, and hunt down a hidden class clown who's sabotaging to try and make the entire group fail. I spent a little over a year making this game as fun as possible while still maintaining some educational value with the trivia. Making this game almost drove me to complete burnout, but I'm really proud of it, so if it sounds fun, grab some friends and check it out. To celebrate the launch, it's 20% off for this week only. Thanks so much for your support, and now let's move on to the next round, round 2. First, take an empty Sprite bottle and fill it up with a bit of root beer. Next, I want to add butane to the root beer, which I'll do using pliers to hold the nozzle while pushing down on the can like this. Once I've added butane to the bottle for about 10 to 15 seconds, I've now got enough butane in the bottle such that when I flip it over, the bottle shoots off like a rocket. A balloon that's inflated with air weighs less than a balloon that isn't inflated, but a drop test doesn't prove that. To actually show it, I've got two balloons of roughly equal size attached to a wood stick that can rotate freely just like a scale. At the start, you can see both balloons weigh roughly the same. However, when I cut open the balloon on the right and speed it up until all the air has left the balloon, now you can see that the inflated balloon weighs less than the empty one. This is a 4x magnifying glass. Although that magnification doesn't seem like much, I can focus the sun on a large match like this, and the match tip will ignite. You've now seen all three videos, and it's time to pause to vote in the comments for which one you thought was fake. It's true that adding butane to a plastic bottle with liquid creates a rocket when you flip it over, and it's awesome to see in slow motion. The butane rapidly expands within the bottle, pushing the liquid out so rapidly that it provides propulsion. It's also true that you can light a match by focusing the sun with a 4x magnifying glass. An empty balloon does not weigh more than an inflated one. In fact, it's the opposite. Cutting the balloon open forces air to leave. That thrust is what initially propels the balloon downward, making it look heavier. However, once the balloon has fully deflated, you can see that the empty balloon actually weighs less. It doesn't have the mass of the pressurized air like the other one does. Here's a quick recap to help you follow before moving on to the next round. Now it's time for the final round, round 3. This is a large jar of peanut butter, and I'm going to spread some out onto a plate, making as flat of a surface as possible. Next, I'm going to put this plate of peanut butter in the freezer for a couple of hours. Once the peanut butter has been chilled, I can now use a blacklight or UV flashlight on the peanut butter to show you that peanut butter is glow in the dark. You can see it glowing for several seconds after I turn the blacklight off, as you can see here. This is some compressed air at around 100 psi. If I take a tennis ball, I can use the compressed air to keep the ball suspended in the air. This doesn't only apply to balls, and you can see this screwdriver is also suspended in air due to the compressed air flowing over it. When UV light shines on water, the water doesn't look that different, but the UV light is actually spreading out the water molecules ever so slightly, making the water less dense. To show this in action, I'll use this ketchup packet, which has almost the exact same density as water. At first you see that it floats in this 2-liter bottle of water, but if I turn off the lights and shine the UV light on it, now you see that the water becomes less dense and the ketchup packet sinks. That is until I turn off the UV light and the ketchup packet once again returns to the surface. You've now seen all 3 videos and it's time to pause to vote in the comments for which one you thought was fake. It turns out peanut butter is glow in the dark, and you can also see this clearly by moving around a blue light laser pointer, causing visible streaks to be shown. The peanut butter doesn't have to be frozen, but it helps it glow more brightly. It's also true that you can levitate different objects using compressed air, and this is an example of the Quadrado effect. It turns out UV light does not change the density of water. I simply screwed on the cap and squeezed the bottle. Then I stopped squeezing when the light turned off. Squeezing the sealed bottle compresses the air inside the ketchup packet, making it dense enough to sink. Here's a quick recap of the final round of Season 4. I'm not ruling out a 5th season, but between making these and working on Stick Scholars, I'm gonna need a bit of a break. If you haven't seen all the episodes from the first 3 seasons, I'll put a link to the marathons of each of those in the description. Thanks for watching to the end, and I'll see you next time.